In the third part of this lecture, we will going to learn independent and dependent events, multiplication law. Independent events. Two or more events are said to be independent in a series of trials if the outcome of one event does not affect the outcome of the other event. Two events A and B are independent if and only if probability B given A. Hopefully now you are familiar with this concept. Probability B given A means, what does it means? Is equal to probability of B, or probability A given B will be equal to probability A. Let's say we perform a random experiment through which we generate some sample space S, and we define any two events, let's say A and B, on that particular sample space. Then the events A and B will be independent events if and only if they both does not affect each other. Like the occurrence of one event does not affect the occurrence of other event. Here we have written that probability of B given A is equal to probability of B. Probability B given A means you have to find the probability of B given that A has already occurred. But if A and B are independent events, then either A occurs before the event B or it does not occur. It will not affect the B because both are independent events. Multiplication law. If the two events are happening at the same time, you need to multiply the two probabilities. Using the questions usually the questions use the word and when describing the outcomes. Like in addition law, we have mentioned that the questions usually carry the word or. In multiplication law, the questions usually use the word and in describing the phenomena. If in an experiment the events A and B can both occur and are independent of each other, then probability A intersection B will be equal to probability of A into probability of B. A intersection B, or you can say that probability A and B, it means that both the events are occurring together. If both are independent, independent means both does not affect each other on the occurrence, then probability of A intersection B will be equal to probability of A into probability of B. If in an experiment the events A and B can both occur and are dependent, then probability A intersection B will be equal to probability of A into probability of B, given that probability given that A has already occurred. Similarly, you can write it as probability A intersection B will be equal to probability of B into probability of A given that B has already occurred. Example number 1. Consider an experiment of rolling a die and flipping a coin. What is the probability of getting a head and a 3 on a die? Let each represent the occurrence of head on a coin and A represent the occurrence of 3 on a die. As you can see here that H and A means head and appearing 3 on a die, both are independent as they both does not affect each other in any means. So we can write that probability H intersection A will be equal to probability of A into probability of H, where H represents the head, occurrence of head in tossing a coin, then probability of its occurrence will be 1 by 2. And as you know that in rolling a die, we have a sample space containing 6 outcomes, and as A represent that getting a 3, then it will be equal to the probability of A will be equal to 1 by 6. By applying the multiplication law for the independent events, we will get 1 by 12. Example number 2. A bag contains 5 red and 5 blue balls. We draw a random ball from the bag, record its color, and put it back into the bag. We then draw another random ball from the bag and record its color. The first case will be for the independent event case. You have to find what is the probability that the first ball is red and what is the probability that the second ball is blue. Solution. Let R1 represents the first ball is red. R2 represents that the second ball is red. B1 represents the first ball is blue and B2 represents that second ball is blue. Then probability that first ball is red will be equal to probability that first ball is red and second ball is also red. Or it can happen in this way that first ball is red and second ball is blue. As you can see from the question that you have to find the probability that the first ball is red. There is no other restriction on the second ball. So it could be red or it could be blue. You have two cases. Either the second ball is red or either the second ball is blue. As we have to find that the first ball is red, we will take both the cases. Now, what will we have? By applying the multiplication law, we will get probability of R1 into probability of R2 given that R1 has already occurred, or probability of R1 into probability of B2 into given that R1 has occurred. As we know that both events are independent event, how we know that? because as you go back to the question, you will notice that it is written that when we draw a ball from the bag and record its color, we put it back into the bag. So it means that the upcoming event will not affect with the previous event. So that's why we can write it as probability of R1 into probability of R2 plus probability of R1 into probability of B2. As we know that there are total 5 red balls in a bag and 5 blue balls in a bag, so we have total 10 balls. By applying the definition of probability of an event, we have number of favorable outcomes divided by total number of outcomes, which would be equal to 5 by 10. Probability of R2 will also equal to 5 by 10 and probability of R1 will be also equal to 5 by 10. Similarly, probability of B2 will also equal to 5 by 10. We will get the probability 0.5. Now, second case is that the second ball is blue. In part B, there is a restriction on the second ball that it should be blue. There is no other restriction on the first ball. So it could either be red ball or it could be blue ball. We have two cases. The first one is that first ball is red and second ball is blue, or it could be first ball is blue and second ball is also blue. By applying the multiplicative law, what we will get? Probability of R1 into probability of B2, given that R1 plus probability of B1 into probability of B2, given that B1. As the events are independent, as we know that when we draw the first ball, we will replace it before drawing the second ball. So what we will get? By applying the multiplicative law for the independent events, it would be equal to probability of R1 into probability of B2 plus probability of B1 into probability of B2. By finding the probabilities, we will get the probability 0.5. Now in the same example, consider that when we draw a ball from the bag, we does not put it back before the second draw. This would be the case for the dependent events. Now, the first one is, what is the probability that the first ball is red? Again, the same question, but now the scenario is changed as we have not put back the first ball before drawing the second ball. Now when we will going to find the probability for the first ball is red, again we will have two cases, that first ball is red and second ball would also be red, or the first ball is red and second ball will be blue. By applying the multiplicative law, what will we have? Probability of R1 into probability of R2, given that R1 has occurred, plus probability of R1 into probability of B2, given that R1 has already occurred, as both events are dependent events because we have not put back the ball before drawing the second ball. Then what will be the probability of R1? It will be equal to 5 by 10. But when we will going to draw the second red ball, as we have already drawn the first ball, red ball, the remaining balls will be, red balls will be 4, and remaining ball in the bag will be 9 because we have not replaced the ball after the first draw. As we know that the probability of an event can be found out by number of favorable outcomes divided by total number of outcomes. So the probability R2, given that R1 has already occurred, that we have already done the first draw, will be 4 by 9 plus probability that first ball is red, that is probability of R1, will be 5 by 10, and probability that second ball is blue, given that first ball is red one, will be 5 by 9 because total blue balls still in the bag are 5, but total number of balls are reduced to 9 as we have already drawn our red ball in the first draw. Probability that first ball is red is now 0.5. What is the probability that the second ball is blue? Now we have restriction on the second ball is blue, where you can have that first ball would be red or it would be blue. Same as the previous case, but now the situation is changed because we have not replaced the ball before drawing the second draw. So probability of R1 will be 5 by 10 and probability of B2 given R1 will be 5 by 9 plus probability of B1 will be 5 by 10 and probability of B2 given B1 will be 4